Today we'll continue writing our TLS client. In the previous video we sent client hello message to the server. It was the first step in the TLS handshake. Today we'll parse the response to that message. But before we begin, I want to move client hello struct to a separate file and also create a few more. The first one is the TLS record, which has two methods, parse and serialize. The second method is already implemented in this function, so let's just copy it. And the next one is handshake message. It will contain headers of all handshake messages, including client hello. The serialize logic for this struct is already implemented here, so we can safely delete this method and move the code to this place. Let's also update the sending logic. Client hello remains unchanged. The handshake message struct contains values indicating that we want to send the client hello message. TLS record contains the same values we discussed in the previous video. And now we can finally move on to the second step of the TLS handshake. We've got the data from the server, and as we know, any message is wrapped in the TLS record. So let's write a parse method to handle it. The approach is the same. We parse each field one by one. As you can see, the record contains a message of type handshake, the protocol version is 1.2, and the length of data is 42 bytes. This is probably a server hello message, but to be sure, we need to parse the header. Let's do it quickly. And as you can see, we've got the message of type 2, which confirms it's the server hello message. I've just copied its structure from the TLS specification, and now we want to parse it. We're gonna be doing it the same way, each field one by one. For the slices, we do the same trick. First read the links, then the actual data. And extensions. We don't really use them at this point, so I think we'll just keep them for now. And now we can finally see that the server sent us the same data as in the client hello message. Ghost TLS server has a few unusual things actually. It doesn't set session ID, even though the TLS specification tells the opposite, but the server can use so-called session tickets. The client can receive session ID from the server if it sends an empty session ticket extension. But it's a topic for another video, so we'll just skip it. Also, the server doesn't send Unix time in the random structure. Instead, it sends more random bytes. It's not critical, the specification tells that Unix time is not necessary anyway, so let's just continue. The server hello message was only 42 bytes long, but the server sent us 1400 more. Let's read another TLS record with the headers, and we've got the message of type 11, which means the server sent its certificate. One more iteration, and the last message is of type 14, which means the server has finished sending its data. Let's parse the certificate and check what's inside. The TLS specification tells us that this message contains a vector of certificates, so we start by reading the length of this vector, which is encoded in 3 bytes. In our case, the server has only one certificate, but let's write the loop to read the whole vector. A certificate can be of variable length, so again, we first read the length, then the actual bytes. Okay, now we can print, for example, the country code. And we've got an empty slice. It's actually fine, because we didn't specify any country when creating this certificate. Let's generate a new one with some country code. And we'll see it appear on the client as expected. Alright, that's it for this video. In the next one we'll finish the TLS handshake and try exchanging some data. The code is available in the description. Thanks for watching.